Melde string experiment. In this experiment, determination of frequency of a metal rod or tuning fork. Recovering apparatus, AC main source, pulley, metal rod, scale, fan, thread and plug. Initially, we measure mass of the pan value calculated and mass of the thread value calculated. Finally, measure the length of the thread value calculated. The given metal rod is electrically maintained in vibration by conducting it in series with a AC source. The experiments conducted in two ways. Transverse mode of vibrations of a string. The Melde apparatus is arranged such as length of the string is parallel as a metal rod. When the metal rod is excited, the rod vibrates in the direction perpendicular to the length of the string. The transverse vibrations are now produced in the string. A small mass is placed on the scale pan. The circuit is carefully adjusted so that the string vibrates in certain number of defined stationary loops. The total length of finite number of defined loops is measured using the meter scale. The average length of one loop L is measured. The weight of scale pan capital M is found using the physical balance. Here M is weight of the fan and weight placed on the scale pan. If M is known, the value of capital M by L square is calculated. Longitudinal mode of vibrations of the string. In this case, the length of string is perpendicular to the vibrating rod. When the rod is excited, the rod vibrates in the direction parallel to the length of the string. Each particle of the string makes a complete oscillations only when the rod makes two complete oscillations. Hence, the frequency of the rod is twice the frequency of the string. This experiment is preferred as the loads of 5 grams, 10 grams and 50 grams and 20 grams. The length of the vibrating loops L and capital M by L square is calculated. Then the frequency of the rod is calculated by the given formulas. Finally, the mean value of frequency of the rod is found by taking the average of the values of two modes. Melde strings experiments calculations. First of all, you already know that find a mass of the thread value is 1 grams is converting kilograms 1 into 10 to the minus 3 kg. The length of the thread value is 2.43 meter. Next is the mass of pan values 13 grams is converting kilograms values. Find mass per unit length value is mass of the thread divided by length of the thread values. So mass of the thread is 1 grams 10 to the minus 3 kg. Then length of the thread value is 2.43 meters. So 1, so it is minus 3 divided by 2.43 is, the output answer is 4.115 10 to the power of minus 4. So this is mass per unit length values, that is for small m values. Next for calculations, the transverse mode turbulations value. Here there is a pan values, already pan mass values is noted for same pan mass values 13 gram, 13 gram, 30 grams. The mass placed on the pan. First you insert for 0 mass. Next is applied for 5 grams, 10 grams, 20 grams, then 30 grams. In this case, the total mass value is 13 plus 0, 13, 13 plus 5, 13 plus 10, 13 plus 20, 13 plus 30. So here is a mass m values, capital M is noted. So in this case, for number of loops formation, 9 loops. For total mass value for 30 grams, 9 loops. Then 80 grams, 8 loops. The 23 grams, 7 loops. Then 33 grams, 6 loops. So 43 grams and 5 loops. So now length of all loops values is 208 centimeters. Okay, this is also same length of all loops 208 centimeters. Next, length of one loops, that is value for L, is 208 10 to the power minus 3 divided by 9. Okay, so you calculate for one loop values 0.231, 0.26, 0.29 and 0.346, 0.416 values. Next we find m by L squares value. Here this value for m values, here this value for L values. See, m value is first case 13 exponential minus 3 divided by 0.231. The answer is 0.056 values. 0.56. The length of value is 13 grams. So m by L squares values. So sorry, this case values for 13 exponent minus 3 divided by 0.231 square. The answer is 0.243. Okay. So next, the 18 grams, m 18 exponential minus 3 divided by 0.26 whole square. The value is 0.26 and 6 values. Next, this value is 23 exponential minus 3 divided by 0.29 whole square. The answer is 0.273. Similarly, this value is calculated 0.275, 0.248 values. So, in this case, for mean value is they add the 5 number of values, divide by 5. The final answer is m by L square is 0.261. Okay, this value 0.261 kilograms by meter squares. This is value for m by L square for transverse mode values. Okay. So, next for longitudinal mode values, the longitudinal modes will be same procedure. For example, pan mass value for 13 gram, 13 gram, 30 grams. The added mass 0 grams, then 5 grams, then 10 grams value. The total mass will use 13, 18 and 23 grams values. Here with the loop formations value is 5 loops, 4 loops and 3 loops values. The total number of string length values 208 centimeter, 208 centimeter, 206 centimeters values. The length of one loop's values we calculate them. Then 206 10 to the minus 2 divided by 5. The answer is 0.41 meter, 0.51 meter, 0.686 meters values. Okay. For example, for next calculation m by L square. The m means for is the total mass values. Okay. The first case value for 13 exponential minus 3 is converting kilograms, then divide by 0.412 whole square, m by L square's value. The answer is 0.076 and 5 values. Okay, 76 and 5 values. The next case for 18 grams, the 18 exponential minus 3 and divide by 0.515 whole square. The answer is 0.0678. The next value is, the m value is 23 exponential minus 3 divided by 0.686 whole square. The answer is 0.048, then 8 values. Okay. The average value is, that's value for total number of values divided by final answers. So, the answer is 0.0765 plus 0.0678 plus 0.0488. Okay. So, this add the 3 values, divide by 3. The answer is 0.064 and 3. So, this value for m by L squares of longitudinal modes. Okay. This is m by L squares value calculated by transverse mode and longitudinal mode values. Next, we find what are the length, what are the calculations m by transverse mode calculations. The frequency is fine for transverse mode. Frequency is n is equal to 1 by 2 root g by mass per unit small length, mass per unit length into m by L squares values. So, 1 by 2 z for 9.8, then divide by small m. Small m's value already calculated, mass per unit length values. That's value 4.115 10 to the power of minus 4. Okay, into m by L squares. So m by L squares transverse mode's value is 0.261. 0.261's value. So 1 by 2 root 9.8 divided by 4.115 exponential minus 4. The answer is 23815.3 into 0.261. So 23815.3 into 0.261. The answer is 6,205.79. So root 6,215.79 value is 78. So 1 by 2 into 78.8. So 78.8 then divide by 2. The answer is 39.4 hits. Like this are transverse mode formulas. Transverse mode, the output result. Okay. So next is the longitudinal mode. The longitudinal's formula is the frequency is equal to root z by mass per unit length into m by L square. Okay. So the z by m values already know that z by m is a constant. Z by m value already know that 23815.3 into m by L square. The longitudinal modes m by L square's value already know that the longitudinal modes m by L square's value is 0.063643 values. Okay. So the formula, the value is 0.0643. The m by L square's values. Now root 238 root 23815.3 into 0.0643 close the bracket. The answer is 39.13. Okay, Hertz values. So like the transverse mode frequencies, then 39. Next is the longitudinal mode frequencies values. Next we get the average frequency is the average frequency n equal to 39.4 plus 39.13 is divided by 2. The average frequency is 39.265 Hertz values. So approximately the value is 39 Hertz, the steel rod frequencies.